is the word set point. So tap that button and then you'll turn your light on. There you go. All blue. We'll change this when we set up for survey measurements a little bit later, but now you can see how you turn it on and turn it off. That looks good. Would you mind going back to the ambient tab? Just to make sure that we've got everything entered in properly. Okay, we have everything entered in properly. There's just no light in that particular room. Thank you. I just wanted to check and make sure everything was fine.
Okay. The other tabs on this window are not being used. Headlight source would be if we had another light source connected to the light source connector. Console light source would be if you had another light source connected to your console. The last one is your total leaf queue. And this can be changed based on which chamber you're using. Obviously, we have a fluorometer chamber that we're using, so we don't need to make any adjustments here. But if you were trying to use this fluorometer on a different chamber, let's say you had, this is a bad example, but let's say you had a big chamber and you are going to try to use the fluorometer on this chamber. In that case, you would need to adjust some of these parameters so that the instrument will properly calculate the light intensity at the leaf plane. For our particular example, there isn't anything we need to adjust. Okay, you could go back to the Fluorometer tab. Okay, now last tab that we're going to go to and talk about for environmental control is your Fluorometer tab. And if you go to your Fluorometer tab and go to the measuring page, these are your settings for your modulated light. So this is the light that is exciting fluorescence that our detector is measuring. And the reason we modulate that light is so that we can tell the difference between the fluorescence coming back from the leaf and the red light that's already in your chamber. So we set up the modulation at a certain frequency, and we're able to then detect the red light coming back from the leaf at that frequency, and we're able to demodulate it and calculate fluorescence from that data. So this measuring beam is really, it's what allows us to measure fluorescence. And you can see there are a few options here. We can, if we're not interested in fluorescence at all, we could just set our measuring beam off, and then we wouldn't be measuring fluorescence. But today we're going to keep it set to on. The other option you could do is have it be set to maximum. And this can be useful if you are trying to optimize your signal to noise ratio and you had a light adaptive leaf. You may want it just to produce as much fluorescence as possible, so you get a really high fluorescent signal coming back from the leaf. It's most common to just set it to being on, and then the instrument will help use the correct settings based on what type of experiment you're using. A couple of other settings that you can choose are what your modulation rate is for dark adapted measurements versus light adapted measurements. In general, I would not change those. I would just start with what we have given you for the defaults. The biggest one probably to pay attention to is your dark modulation rate. And you'll notice next to each of these settings, it shows you what your light intensity is based on the modulation rate you have set. So when you have a dark adapted leaf and you are trying to measure FV over FM, or your dark adapted maximum fluorescence yield, it's really critical that you do not start start driving photosynthesis. So if you notice with this default modulation rate, if you put a dark adapted leaf in the chamber and you notice the fluorescence signal continuously climbing, then that is a good indicator that this light level is too bright for the leaf. And you may need to decrease your modulation rate so that the light intensity is lower. So you can see this is a very low light that we're talking about. At our default modulation rate, we're only putting 0.05 micromoles of light on that leaf. So it's very, very small. So I would say for most leaves, these settings are perfectly fine. But you may find, especially if you work with shade leaves or leaves grown in a low light level growth chamber, you may notice that the dark modulation rate is too high, and that one may be needed to be adjusted. But that's pretty unusual, I would say. These settings are pretty appropriate for most situations. Another feature, the other settings you really don't change. The only other one that you might be interested in is actually recording a fluorescence trace. And what this does is it actually takes the raw fluorescence and light that the fluorometer is measuring, and it saves that raw data into a separate data file. So if you ever wanted to go back and replot an entire experiment's fluorescence information, you could do that. And you can start and stop that recording from this screen. Okay, the other settings here, the multi-phase, rectangular, induction, and dark pulse, these are all different fluorescence tasks that you can do. Multi-phase, rectangular, and induction are all different types of saturating flashes that you can use with this fluorometer. The multi-phase flash is most appropriate for highlight grown leaves. So if you're working with field grown plants, we would encourage you to use the multi-phase saturating flash. If you are working just with dark adapted leaves, you're only measuring FV over FM, or you're working with really low light grown plants, then the rectangular flash is the better choice. Induction flashes are a special type of flash, and they allow you to measure the transient from dark to light and the induction of your light reactions, sometimes called OJIP, OJIP, or induction kinetics. Those are two terms that you'll see in the literature that specifically talk about induction flashes. Typically, induction flashes are only done on dark adapted leaves. And again, the whole idea is you can see how specific leaves adapt to a dark to light transition. And you can see how quickly it takes specific leaves to induce the light reactions of photosynthesis. It can be really useful to look at induction flashes on leaves that have been exposed to different types of stresses. And you'll see how the parameters of the induction flash change based on the type of stress that that leaf has been exposed to. So you may find that that information is useful. Dark pulse allows you, I could click on these. Dark pulse allows you to set up the parameters to measure F0 prime. And if you recall from Elizabeth's presentation, F naught prime is needed in order. And basically what you do is you turn off the light, the ambient light, for just a few seconds, and you apply a little bit of far red light for a few seconds, and then you make sure that the chamber is dark, and you record what is the minimum fluorescence from that leaf once it's in that state. And that is labeled F naught prime. And that value is used then to calculate QP and QN. Okay, so there are different settings that you can use and optimize based on your plant material. Again, I would probably start with the defaults that we give you. And if you notice that the time is not adequate for fluorescence to reach a minimum value, then you can start adjusting these parameters, the timing or the target. But in general, these settings should be okay for most leaves. The results tab is really nice because it shows you a snapshot of the last fluorescence measurement you did. So this is a bad example because I don't have a leaf in the chamber and I have no idea what this data is, but it's nonsense. But if I had given a saturating flash, it would show that value. It would show a trace of that data, and it would actually calculate what my fluorescence parameters are based on that data. So as you start working with a fluorometer, it will be really useful to look at this page and kind of understand how well you have the fluorometer set up, and then how that data looks as you collect it. You can do some quality control and quality check of your data. Files allows you to recall data you collected earlier. So you can see on my screen right now, I'm plotting 4 different multi-phase flashes that I have done previously. And you can turn them on and off. So if I only want to look at my first flash, I can turn the other ones off and just be able to take a look at that one flash. If I wanted to look at just the top portion of the flash, I could zoom into the data and maybe look at the top 10%, and that's still not enough. Let's say 30%. And then I can really zoom in and take a look at the details of that flash and check to see if I have good data or not. Up at the top of the screen, you can toggle between looking at the data in a graph, or you could have it take the data and put it into a table for you. You can decide what parameters you look at. So I'm going to only look at my multi-phase flash parameters. And for the 4 different flashes here, you'll notice there's a separate column for each flash and kind of a summary of the data. So things that I would be looking for, I'm looking here at my first multi-phase flash, 141. If I look at the table here, it's this first column here, okay? So if I want to see at a glance, what was my steady state fluorescence value? What was my phi PS2 that I calculated? This is your effective quantum efficiency. You could interpret that as about 72% of the absorbed light is being used for photosynthesis on this particular leaf. So this leaf is operating with very high efficiency. It's using 72% of the light that it's absorbed in photosynthesis. So this leaf is actually a very happy leaf. So again, you can just see a nice snapshot of all of your parameters. And as you go to try to adjust your settings on